At some point when we start doing calculus, it's going to be necessary for us to know how to solve polynomial inequalities pretty quickly. So what I'm going to do is just show you how to do that. First, I want to do a little review about polynomial behaviors. In specific, I want to talk about end behavior. So that means, what does a polynomial do for really large values of x and for really negative values of x? And there are two things that govern polynomial end behavior, and that's the degree of the polynomial and whether the lead coefficient is positive or negative. So I'm going to make a chart here, the degree and the lead coefficient. Now, if the degree is even and the lead coefficient is positive, then the end behavior that the polynomial will have is it will rise right and it will rise left. It'll do the same thing in both directions. Now, that doesn't tell us what's going on in between, but right now I'm not too worried about that. All that you need to know is that it rises right and left. If the degree is odd and the lead coefficient is positive, then what's going to happen is it's going to fall left and rise right eventually. Again, none of this says anything about what's going on in the middle. I'm just talking about end behavior. And if you remember from transformations, if you multiply a polynomial by a -1, it flips everything around the x-axis. And so if it has an even degree and a negative lead coefficient, it's going to fall left and fall right. And negative lead coefficient and odd degree, it's going to rise left and fall right. So that's what we need for now. What I want to do now is sketch a couple of these. Now, what do you need for that? The important parts of polynomials are the end behavior and the zeros. So I want to give just want to give a rough sketch of, let's say, x times x minus 1, x plus 2, y equals. And so we have, you draw out your axis and you mark down the zeros. So it's 0 at 0, and it's 0 at 1, and 0 at -2. Now, if you were to multiply this thing out, it would be third degree. So, and with a positive lead coefficient, so it's going to fall left and rise right. So the way it's going to look is it's going to look like this. And that's it. That's all there is to it. No matter how much I jazz this up, there's only so many things that I can throw at you here. But what I want to ask right now is, what if I asked you to solve the inequality, this, x times x minus 1 times x plus 2 is greater than 0, or greater than or equal to 0. What would you do? A lot of students want to do something like this. When they see these things, their first instinct is to take each of the factors, x minus 1, x minus what is that, plus 2, greater than or equal to 0. What they want to do is they want to take each of the factors and set them all greater than or equal to 0, just like they would do for an equation if it equaled 0. X plus 2 greater than or equal to 0. So usually, now this is incorrect, but they set this up and they would say something like x is greater than or equal to 0, x is greater than or equal to 1, x is greater than or equal to -2, and that's the answer. But this is incorrect. You can only do that if this is an equation, right? Because if you have the product of three different factors and they all multiply out to equal 0, then it stands to reason that at least one of the factors must equal 0. So in that case, that's why we set them equal to 0. X minus 1 equals 0. X plus 2 equals 0. And we correspondingly get the answers x equals 0, x equals 1, x equals -2. But when it's an inequality, the rules go out the window. You can't treat it that way. It's a completely different type of thing. Because we're looking for values of x that make this entire expression positive. Not just the individual factors. When you set these things individually greater than 0, all that you get is the condition that makes those individual factors positive, right? If x is greater than or equal to 1, then the first one is going to be positive. But that doesn't tell you about what the other ones are. We want the combination of all three to yield positive numbers. But, fortunately for us, the answers are right in front of us. Normally, this plays the role of the y-axis, but in this case, I'm going to ask you to look at it as though it's this axis. Okay? This axis here. If the graph is plotted above the x-axis, then that means this expression is positive. And if the graph is plotted below the x-axis, that means that this expression is negative. So from the graph that you're looking at, the solution to this inequality is x is between -2 and 0, or x is greater than or equal to 1. These are the answers, and we use the graph exclusively to arrive at this answer. If you don't have a graph, and unless you know what you're doing, there's really no way to figure this thing out. But look at it. Once again, some students have a hard time seeing this. Check it out. If x is in this region, then x is greater than 1. And all three of these factors are going to be positive. Hence, when you plug in this value of x, it gets plotted up here. It's plotted above. That means it's positive. When we come over here, if I plug in a value of x between 0 and 1, it gets plotted down here. And so values of x inside this region make the entire thing negative. So we don't want those. But when we go back in here again, numbers between -2 and 0, if you plug them in, when you plot it, it's plotted above, and they yield positive numbers. And then we have negative numbers back down over here. So you use the graph to figure out what the solutions are going to be. It's all about knowing how to read the graph that you're looking at. Now I want to go into a slightly deeper analysis as to why this is the way it is. If we take that same equation, x minus 1, x plus 2, and we want this, we draw out a number line here. I want to plot where is this thing equal to 0. So it's 0 here. At 0, it's 0. And at 1, it's 0. And at -2, it's 0. Now look what happens with the signs of the factors. If we make x greater than 1, we said this is going to be positive, that's going to be positive, that's going to be positive, so we have positive times positive times positive for a product of positive in total. Now what happens when we cross over here? Alright, when we cross from this side to this side, this factor changes sign. These ones don't though, because we haven't crossed over 0 and we haven't crossed over -2. But just going over here, exactly one of the factors changes sign, and hence it changes the sign of the entire thing. Now we have positive times positive for a total of negative. When we cross over 0, we go from this kind of situation to switching this sign. And that's going to give you negative times positive. And again, it's going to flip the sign of the entire thing back to positive. And then finally, when you go over to less than -2, all three factors are negative because this last one changes. Negative times negative gives you a total of negative. And notice that the solutions match the thing that we came up with. And it is, of course, no coincidence that if you were to plot this, this is what the graph would look like. Alright, it's above the axis where everything is positive, and it's below the axis where everything is negative. Now, that's easy because we knew that we knew where the zeros were, and we knew what the end behavior was. We knew that it was third degree, so it had to fall left and rise right, and it had these 3 zeros, so this was the only way it could look, right? Well, maybe. Try this one. I'll put the same thing up and I'll ask a question. X plus 2, y equals. Now we said it looks like this. Something like that. And it's true. It does. But why does it look like this and not say, well, it's got to have these 3 zeros here, and not something like this? Well, you might say that that's incorrect because it's a third degree positively coefficient, so this would violate the end behavior. And that's true. You'd be right. That's out. But another question is, why doesn't it look like this instead? Got these zeros. Let's see. What about this? Isn't it at least possible that the graph could look something like this? I mean, it's got this. It's got all the right zeros, and it has the right end behavior. What's going on? Well, the reason that it looks like this one and not this one is because of the powers that are associated with each of these roots. All right, there are phantom ones here that we never really write. If these numbers here, if they're odd, then the graph of the function will cross the x-axis at those points. So if it's odd, that implies a cross. All right, the graph is going to cross over the axis at those numbers. However, if the powers are even, let's say we had a 2 here, then that means that the graph will not cross the axis and it will merely touch. Or we might say it bounces. It could be a bounce. Touch or bounce. It will not cross at those at the roots that appear an even number of times. So it's all about even and odds for these numbers. Let me give you some more examples. If I have, say, I'll start you off with x squared, x minus 3, and I tell you to generate a graph of this. Draw out the axis. Say, where is it 0? Y equals, it's going to be 0 at 0, okay, 0 at 3. So 3. It is a third degree polynomial, so it's going to fall left and rise right. And according to the rule, since it's going to have these two numbers as zeros, but this one here, since it has an even number associated with it, that's an even power, the graph is going to just touch the axis at that point and continue downward. And then this one here, since it has a 1 here that's acknowledged, that's an odd number, the graph is going to cross at that point, and it's going to generate this graph. So if I wanted to solve the inequality greater than or equal to 0, you would just look at the graph and say, okay, that's going to be values of x that are greater than or equal to 3, and also x equals 0. So the graph tells you a lot about how to solve these things. Let me just do another one really quick. If I say y equals, we'll say x minus 2 cubed, x plus 1 squared. Again, it's the same deal. Draw out the axis. Where are the zeros? So at minus 1, it's going to cross the. It's going to contain that point, and at positive 2, it's going to contain that point. You look at it. The degree, if we were to multiply all this out, would be degree 5. So that's odd. It's going to fall left and rise right. So as we go to draw this, all that we have to do is decide whether these are touches or crosses. So I come up, the x plus 1 has a square on it, so that's an even power, so that means it's just going to touch. And this one has an odd power attached to it, so that means it's going to cross. Now this is a really crude drawing here. All right, it's not supposed to be a really accurate depiction of what it looks like. In reality, the graph will look something like this. It's definitely going to come up and touch here, and then it'll come back down. But because this power is so high on the 2, it'll come up and kind of do something like this. It'll flatten out a bit, and then it'll keep on going up. But we don't really need a totally accurate description of what's going on, because we're only out to figure out what the signs are of these. We're only solving inequalities, so we don't need a really detailed sketch. We just need what the basics are. So in this case, if we were solving this inequality, again, same deal. You'd say, oh, it's 0 there, so x equals 0 would be an answer, and x is greater than or equal to 2. That's where it's above, and that's the end of the story. Now the question is, why do the even ones cross? No. Why do the even ones bounce or just touch the axis? And why do the odd ones cross? What's the difference? Well, if you play this game with the signs, let's say we have y equals, we'll go with x squared, x minus 1, and then x plus 2 quantity squared. Alright, so what's going to happen here? Let's see. Let's mark down our zeros first. So we have minus 1, 0. No, we have positive 1. I'm sorry. 0 and negative 2. Now, according to this, it's going to be a. Is it going to be a touch or is it going to be a cross? It's going to be a touch or a bounce. Is it going to be a touch or is it going to be a cross? It's going to be another bounce. This one is going to be a cross, but watch this. Let's take a look at these three factors and how the even power affects how everything turns out. If you pick numbers, alright, hope we can still see this here. Yeah. Let's just go with, here's minus 2, 0, and 1. We don't really need the y-axis here. If we're on this side, if we pick values of x that are larger than 1, all three factors are going to be positive because x is greater than 1, x plus 2 is positive, x minus 1 is positive, and this is positive. So we get positive, positive, positive for a total of positive. Now, when we cross over 1, we said earlier, exactly one of these factors changes sign. This is the one that's going to change sign. So we're going to go from plus 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 to plus minus plus, thus changing the sign of the entire thing, and we'll have it'll all be negative. Write that down, negative. Now look carefully. When we cross over 0, the factor that would have the opportunity to change sign would be this. However, since it has an even power on it, this is always going to be a positive number, regardless of which side of on which side of 0 we are. So plus 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 minus plus, because of this even power, this factor is not going to change, and you're left with the same sign that you had on the other side of 0. Alright, the even power is what does that. Similarly for this, when we cross over here, if this were an odd power, or just a 1 say, then this would change sign. However, since it's got a square on it, it's not going to change sign on either side of 2. And you'll again be you'll have the same situation, minus. So, because we get the same sign on both sides of these zeros, that's what constitutes a bounce. What is the degree of this? This was a 2, 1, 2. It's a 5th degree. It's got a, if you can see this, it's got to fall left and rise right again. So this one would look like, well, I could just graph it up here. This will look like it's negative, it'll be a bounce, stays negative, bounce again, stays negative still, and then crosses up through that. Alright, because that was the one that had the odd power, so that changed sign. And the solution of this inequality would be x equals 2, negative 2, x equals 0, or x is greater than or equal to 1. Let's see what else we can get going here. Let's try another example real quick. Let's go with y equals x plus 2 again, squared, and then I'll say x minus 4. Okay, so the ultimate goal here is to solve this inequality. So let's use a graph to see how this goes. We can generate this up since we know how everything behaves. All we need to do is draw this out. So the zeros are 0 and negative 2 and 4. 1, 2, 3. No, 1, 2, 3, 4. It's a 4th degree with a positive lead coefficient. So it's going to rise right and left. So when we start to draw, we're going to come down here. And is it going to be a cross or is it going to be a touch? It's going to be a touch because that factor has an even power, so it's going to just kind of bounce off. And then it's going to cross at 0 and cross at 4. So the way it's going to look is like this and like this. something like that. And if we want to solve the inequality, greater than or equal to 0, whereas a positive, it would be x is greater than or equal to 4, right? Everything over here, and x is less than or equal to 0, because everything over here makes the whole thing positive. Now, we can get really slick with the way that we do these. You really don't need a graph if you really know what you're doing. You could have something like, say, x times x minus 1 squared times x plus 2, and say even x plus 3 squared. Well, guess we don't need that. If I want to solve this inequality, all that you really need to know is where the sign changes are going to occur. So you just draw out the x-axis here. Mark down where it equals 0. So it's at 0, it's 0. At 1, it's 0. At negative 2, it's 0. And at negative 3, it's 0. So then all that you have to do is, we don't need to graph anything. We just need to think a little bit. All that you got to do is pick a number larger than the largest 0. So pick a number, any number greater than 1, and plug it in. Now don't actually work it out. You don't have to work it out. You just have to determine whether the entire thing is going to be positive or negative. So if I plug in a number greater than 1, every factor is going to be positive, so I'm going to get in total positive. And then the question becomes, will we get sign changes when we cross these individual zeros? So, will we get a sign change when we cross over 1? And the answer is no, because the 1 has an even power attached to it. So I just say positive. What about when we cross from here over to here? Well, 0 has an odd degree attached to it, so that will incur a sign change. And then what about when we go from here to here? This only appears one time, and that factor is going to switch signs, so we say yes, sign change. And then will we get another sign change when we cross over minus 3? The answer is no, because the x plus 3 term has a even power attached to it, so no sign change. So you could just look straight up at this, and if you want to solve where is this greater than or equal to 0, read it right off of the chart. X is either less than or equal to minus 2, or x is greater than or equal to 0. That's it. That's the way it goes. On occasion, you might come up with some things that are a little bit more difficult. Sometimes I like to switch it up. Say we're solving something like x squared plus 1, and then x squared minus 6, say, greater than or equal to 0. So solve this inequality. First thing that you want to do, you realize that we can only really make a move on this if it's factored completely. So I'll factor it completely. I'm just going to put this term out in front. I'll tell you why later. X squared plus 1, and then there's an x squared, and this is a difference of squares. That's going to factor into x plus radical 6 times x minus radical 6, and we want greater than or equal to 0. Once it's all factored out like that, no big deal. You treat it just like this. So you draw it out. Where are the zeros? This contributes a 0 of radical 6 makes it 0. This makes it 0 at 0. This makes it 0 at negative radical 6. This doesn't contribute any zeros, so it's not going to give us any additional zeros in here. What role does this thing play? Since it doesn't give us any zeros, it's not going to contribute anything to the sign chart, really. Notice, for any value of x, any value, this just acts as some positive number. Alright? No matter which region x is in, this is just a positive quantity. So if I were to draw out write out the individual factors here, like plus, minus, plus, plus, this thing would always have a plus. So for purposes of doing our sign chart, we can just ignore this. It doesn't make a difference. It's going to change what the subtleties of the graph are going to look like, but again, we're not interested in that. We only want to know where is it positive, where is it negative. We're only looking to solve the inequality. So, plug in a number greater than radical 6. Clearly everything is going to be positive, so we write positive. When we cross over radical 6, this factor changes sign, so negative. When we cross over 0, 0 has an even, appears an even number of times, so that will not incur a sign change. And then finally when we cross over here, this factor will change sign, and we'll get something like this. So if I wanted to know where is it greater than or equal to 0, just look at the sign chart, and you say x is less than or equal to negative radical 6. X is greater than or equal to positive radical 6, and since it's or equal to 0, don't forget about x equals 0. Now, that's all we have for solving polynomial inequalities. They do get a little bit more difficult when we start throwing fractions in there and such, but basically it's going to be the same thing. Given this, you should be able to solve any polynomial inequality, or solve, let's say, if this is just a random graph, f of x, no matter what it is, as long as you know what these zeros are, let's say false, let's say that this is minus 5 and 1 and say 4 here. If I give you just this and I say, here we go, if I just give you this and I say solve this inequality, f of x is greater than 0 or equal to 0, all that you have to do is look at the graph and see where it's negative, which values of x make it negative, which values of x make it positive. And so the case would be, to solve this, x is greater than or equal to 4, or x is between minus 5 and 1.